Hi everybody. Now we are continuing our discussion on using graphs to relate two quantities, and this time we will be creating the graph. We will be visualizing a scenario and use our graph to show the movement or the comparison between the quantities. Okay. So if you're going to take a look at this particular scenario here, we have a model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. So what we need is to represent that whole story. How will the graph look like? How can we represent the movement and the height of the rocket during the entirety of its flight? Okay, so first thing we have to define our variables. Okay, what we are trying to compare here would be as the time passes by. Okay, so our independent variable here would be our time, so that's t, and we are trying to compare the height of the rocket. Height of rocket. Okay, so this is our h. Okay, so let's go through each part of the story. Okay, so of course we have a rocket, and where does your rocket start? It starts on Earth. Okay, so its distance from the Earth is 0. So it starts here, and then it says here that the rocket rises quickly. So how can you represent that rises quickly? Okay, so a quick rise would be something like this. Okay, it's a quick rise. Okay, now according to the movement of the rocket, it then moves slowly until it stops. Okay, so there's a slow until it stops because that's when the fuel of the rocket burns out. So from this movement here, it has a quick rise, and then it will now go slowly until it stops. And so let's have from here, it will stop. Okay, so that's the stop. Okay, that's where the stop will be. Okay, now after the fuel burns out, it begins to fall quickly. Okay, so it's gonna go fall quickly. So let's represent that next one. So after that's the fuel burnout, it will fall quickly. So you can have it this way. Oops, sorry. Oops, my bad. Okay, so it will fall quickly here. My goodness, it keeps on turning. My good Lord. Okay. My pen is not cooperating. So it will fall quickly. So something like that. Okay, until the parachute opens. So at certain point, that parachute will open. So let's say it's gonna be somewhere here. And what will happen? It will fall slowly back to Earth. Okay, that's the important part there. It says falls slowly until it hits back to Earth, meaning what will be the end point? It will be going back to 0. So from where the point where the parachute opens, you can have a slow, oops, sorry, it should be a straight line. Just pretend that this is a straight line, okay? So it will go slow until it hits back onto the Earth, okay? So basically, this is how the graph of the whole flight would look like based on the descriptions, okay? So again, from here, let's go over those things here, okay? So this is the quick rise. This is the quick rise. And then this is the stop. This point here, that's the stop. Okay, that's when the burnout happens, okay? And then this point over here, this is when your parachute opens. Okay, I don't know what happened to this purple line over here, but there should be a purple, that purple line should have ended until 0 here. So it's gonna be until here, okay? And then that's when it landed back to Earth, this part here, okay? So that's how you can sketch a graph by following the description of the movement in this particular scenario. Okay, let's have another example. And for this time, I would like you to try this one on your own. So I'm pretty sure that some of you have already done swinging when you were kids. Okay, so imagine that you are swinging yourself in a playground swing. You know that you have to move back and forth, and then of course, definitely you would like to swing higher up in the air. And so the scenario here is you will be swinging back and forth, you get a maximum height, and then later on you will have to stop the swinging. So I would like you to represent that into this graph. Go ahead, try it out. All right, so when you're talking about swinging, okay, you will be considering two variables: time that you spend when swinging, and then of course your height from the ground. Now you cannot start your height from the ground at zero, because definitely you are lifted up a little bit. When you are sitting on your swing, you are not sitting on the ground, you're at a certain height. So that's your beginning height for your swinging. And so as you can see here for this yellow graph part here, okay, where's my cursor there? So from where you are sitting, definitely you have to move backward first. Okay, so when you're moving backward, your height is increasing. Okay, and once you have hit a certain height that you can, like, the highest that you can push yourself backward, and then you're gonna let go of yourself, and then it's gonna go swing forward. Okay, and so it's gonna go from high going low, and of course you're gonna be kicking a little bit more, and so the tendency is when you're swinging backward, you'll have a higher height to reach. Okay, and then again going back and forth, and then of course you want to hit the highest swing that you can, so you kick some more. When you hit the lowest point, you kick some more, and then it's going to give you your highest point on the swing, and so on, like that. Okay, so it's going to go forward. Now if you stop kicking on the ground, so that you will no longer gain some more height, so if you let the swing go by itself, okay, so you know that the height of your swinging will go slowly shorter and shorter, lower and lower, until eventually your swing stops already. So basically this is how you can represent the movement, your height from the ground, when you are doing a back and forth swinging using the playground swing. Okay, so that's our example. And so to summarize our lesson, you can use graphs to visually represent relationships between two variable quantities as they both change. All right.